Hey everyone, we're today going to do highest common factors and lowest common multiples. Okay, so we're going to start with...
Sorry, I'm late. Hi, yeah, class is ready, off you go.
We're going to start with factors, okay? So what is a factor? Can anyone name me a factor of 12? 7! 7 is incorrect. 7 is not a factor of 12. A factor of 12 is a number that will divide into that number. So we're thinking about 12. Factors tend to come in pairs, okay? We're going to think about pairs of factors because that number times that number will give you your number here. So can you think of two numbers that would multiply together to make 12?
1 times 12.
1 times 12, brilliant. So there we go, I've got two factors already, 1 and 12. Any others?
3 and 4.
3 and 4. 2 and 6. Do we have any more?
6 and 2.
6 and 2, we've already got 2 and 6, so we don't want 6 and 2 as well, because then we've finished it there. A good way to think about it is to go through it from 1, then 2, then 3. So if I erase this bit here, and go back onto here, if I go 1 and then I think about 2, does 2 go to 12? Yes it does, because it's an even number. So 2 multiplies with 6, then does 3 go in? Yes it does, and that partners with 4, and we're done. Okay, there isn't 5's not going to go in, and then we're back to 6. So we've kind of made a loop there with our factors.
How do you spell banana?
Oh, where is the banana?
Exactly. Where is the... That is a question for you. Where is the banana? Keep an eye out for it.
Keep thinking. So, factors we've got sorted, okay? The next thing that we're going to have to think about for Alison is the word prime. Now, whenever we ask you guys prime, you give us this jarbled definition. Mr. Casey, can you do an impression of the jarbled definition of a prime number?
A prime number has two... It's divided by 1 in itself.
What does that even mean?
Divided by 1 in itself.
To me, that doesn't really make much sense at all, okay? When I'm thinking about prime numbers, I'm thinking of a number that only has 2 factors. Factors again.
Factors.
1 and itself. 12 is not a prime number because it has more than just that.
1, 2, 3, 4, 5, 6.
Has
6 factors.
6 factors, okay? But if it only had 1 in itself, if it only had 2 factors, then that would be a prime number, i.e. 13. 13, the factors of 13 are just
1, 13, nothing else.
nothing else. So that is what makes it prime.
2 factors. Why is 1 a prime number then?
1? What are the factors of 1? What number's going to 1?
1 times 1.
Just 1. And 1 times 1,
same factor,
number,
one number.
same factor. Okay. So your prime numbers, and attached on your show my homework, there is a video and a song of all the prime numbers, which I found quite hilarious. So do have a look at that. But thinking about our prime numbers, how do I refresh here?
Oh, you're trying to get rid of everything?
Yeah.
Press that one there.
Magic.
Oh.
Okay. So if I'm thinking about my prime numbers, my first prime number is 2. Then next?
3.
Then 5. Then 7. Then 9? No, not 9.
3 times 3.
3 times 3 and 1 and 9. So therefore it is not 9. But what about 11 and then 13 and then 17
Ooh.
and then 19, and we could go on forever, but really foundations and hires, they're really the ones that you must know.
And as Jacob would tell you, there is an infinite number of prime numbers.
And also you can get paid a lot of money to find the next
And an
prime
infinite number of non-prime numbers, which again is 2 infinities. Oh, infinity. Anyway, back to this.
So, primes. They're your primes and they're super duper important. Okay, the next thing we're going to do is something called prime factor decomposition, which sounds really difficult, but it ain't. So, let's start. Give me a number, Mr. Casey. What number should I begin with?
52.
52. Now, we're going to link off 52 into 2 of its factors. Now, the thing that I know about 52 is that it's even, so which factor should I begin with? What number would definitely go into 52 because it's even? The number 2. So, 2 times what gives me 52? If I have my calculator, of course I can use it. If I don't, then I should probably be using bus stop, but I do know that it's 26. Now, out of those two, are either of those two prime? Thinking back to our previous video, we have one that is prime, and that is the number 2. Now I've got to go off on 26. Two numbers that multiply to make 26. Now again, 26 is even, okay? So, therefore, I know 2 goes into it. 2 goes into it, that's a prime. 2 times what makes 26? 2 times 13. Hey, that was one of our primes as well, and we're done. Once you get to 2 primes, you can end. What's next, Mr. Kasem?
You're going to list them out?
Good idea.
List them out.
Prime factor decomposition,
List
or
them out.
known as a product of prime factors. Product means times. So a product of prime factors, we're going to have 2 times 2 times 13. Could we write that a different way? Could we write 2 times 2 times 13 a different way? Yes, we can, because we can write 2 times 2 a different way. It's 2 squared times, oh, Mr. Casey, that was a cube. 2 times 2 squared times 13 equals 52. And now we've done prime factor decomposition. What we would like you guys to do is to have a little bit of a practice and do it for the number 18 and do it for the number
90.
90 is a good one. And what about one more? I quite enjoy the number 36, just for fun.
36?
So, you guys have a go at that. Pause the video for now, so pause it. And now we're going to go through those ones.
Do you want to make that bigger? See this, see this.
Ooh, ooh, look at that, it's so magical. Look at that. Do we want to have, we're going to have 18 and 90. I'm going to do those two. 36, the answer for 36 is 2 times 3 times 2 times 3. So it's 2 times 2 times 3 times 3. So if you got that, well done. But I'm going to go for these two. Okay, so let's go with these two. Two numbers, and they're both even. So a great way to start is dividing them by 2. So 2 times 9. Oh, 2's a prime number. I'm going to circle that in a nice pink colour because that's really nice and pretty. And 9 is not a prime number, but what are the two factors of 9, Mr. Casey?
3 and 3.
3 and
both
3.
Prime,
Both
so you need
prime.
to circle those.
Oh. And we've got 3 and 3. Perfect. Now I'm going to go with back to my 90. Now 90. What I like about the ones beginning, we could go with 2, but also, because it's a 9 and a 0, I know obviously that that's going to be 9 times 10, because everyone knows their 10 times tables, don't they?
Beautiful.
Neither of those are prime.
Oh.
So I'm going to partner off there and do both of them, but I must make sure that I circle
primes.
Okay, so we've done our tree. We need to write out our factors. That's super duper important. Our prime factors, a number that is both prime and a factor. And this leads us nicely on to finding our HCF and LCM using Venn diagrams. So let's move the page up, Mr. Casey.
Okay.
Oh, I need to still see those numbers. Beautiful. What's a Venn diagram? Is it like this? Is this a Venn diagram?
No, that's a histogram.
That's a histogram? Histogram or a bar chart?
Or a bar chart. Yeah, that's a bar chart. Why is that not a histogram?
Because there's gaps between the bars.
Gaps.
What about oh, I've got one, because I think it involves circles, doesn't it?
Yeah.
Is this a Venn diagram?
No.
What's that?
What you want circles.
I want circles.
I think you want something that looks a bit like. Oh, can I just rub that out?
Don't want that left.
Don't like that. You want something that's kind of
Oh.
circle. And
what's that one doing?
Don't like that one at all. I'm going to go back one. Oh, I think I'm meant to go from there.
Oh, beautiful. Oh, they're a little bit misshaped. One fits
That's
smaller
not
than
bad.
another.
That's not bad. You try it. It's not bad. I mean, I could make it a bit bigger.
Yeah.
A bit better.
Bit more.
I'm leaving that. That's good.
Is that
That's
good enough?
I'll tell you, I've done a good job there. I don't know.
Right, we want to label them.
Better than your circles. Just saying.
We're going to label this one 18 and we're going to label this one 90.
Yep.
Now remember what happens. The middle of the Venn diagram, that's what they have in common. Now what do my two numbers have in common? They both have 1, 2. So I'm going to put 1, 2 in the middle. What else do they both have? They both have a 3. So we can pop him in the middle. And they both have another 3. So that one can go in the middle as well.
There's nothing in here.
Is there any numbers left for 18?
No.
No. Is there any numbers left for 90? There's a 5 that looks like an S. I apologise. There is a 5. Now we've done a Venn diagram, we're so nearly there. It's beautiful. It's looking fabulous. Now we've got to bring up these two things, which was what I said to you, this is what we were doing today, and we've barely even spoken about them. What are they?
Huge carnivorous forest. Lazy. Don't know.
Don't know. Highest common factor and lowest common multiple.
Yeah, highest common, of course, highest common factor.
The highest common
Lowest
factor
common
is
multiple.
the highest number that will divide into both of my numbers. So both 18 and 90.
Common, does that mean it like hangs around one stop and like, is that what common is?
Common means it's in both.
Oh, it's in both.
That's what they have in common.
Oh, common.
Okay.
Right.
Lowest common multiple is the lowest number that would be in both of these times tables. Okay. So, highest common factor is your numbers in your
just a little bit.
In the middle bit multiplied together. What do we call the middle bit?
Crossover bit, isn't it? It's the crossover.
In a Venn diagram.
2 times 3. Beautiful.
Which is 18. Lowest common multiple is all of the numbers multiplied together, year 11, unlike all of you did on your first question on paper 1, is all of the numbers multiplied together.
2.
So it's 2 times 3.
3
times 3
5.
times 5, which is 90. And we're done. We're going to do one more example.
Let's do another one.
We're going to do one more
We're
example.
Speed it up.
All from the beginning. Yeah, I'm going to go a bit quicker.
Wipe everything.
Going to go. Give me two numbers.
Two numbers. Two numbers from the audience.
Oh, 72.
72.
And another one? 108. 108. Oh, I like those. I like
108.
Shout out to Miss Law at the back of the room.
Thank you, Miss Law.
So, 72, it's even, so I know 2 goes in. 2 times 36, hey, there's a prime. 36.
Yep.
Easy, I know that's 6 times 6.
Yep.
Neither of those are prime. 6 is 3 times 2, and 6 is 3 times 2.
Circle.
And they are all
Circle.
prime. I'm going to list them out.
Go on
I've got 2, and a 2, and a 2, and a 3, and a 3. Tip, it is good to list them out in order. It helps you look at what they have in common later on.
Like, it's always good to do stuff in order. Keeps your brain functioning.
108. I know that's 9 times 12, just because I love that times table. But I could do 2.
2 times something, you could do lots
2
of
times
things.
half, 54. I could also, guys, you've got to remember this, I could also do any one that I want to do. You don't have to do them the same. You can do them in the times tables that you remember. You can stick with 2s, you can stick with dividing it by 3. It's completely up to you.
9 and 12, I like 9 and 12. Because it breaks it down into nice numbers.
And then we've got,
3, 4.
and that's nice. And look, all these primes.
That's not.
That one's not prime.
No.
Got to keep going with that one.
2 and 2.
And that is gorgeous. And we're going to say, we've
List
got
it.
2 times 2 times 3 times 3 times 3. So I've done that, and that's probably like a mark, but it's still good.
A little bit of space.
A little bit of space. We're then going to have a Venn diagram drawn beautifully.
Okay, stop. This is how you do it. Oh.
See, this is what I mean. They need to be.
Look,
we need a bit of consistency
you want
here.
consistency? Okay. How about that?
No. What is wrong with
What
you?
do you mean? That's nice.
That
What do you
is
mean?
so smaller.
That's not so smaller.
Yeah, that will do. That will do, year 11, that will do. That will do. So, looking at what I have in common, now that I've got them in order, I can see I've got two twos.
1 metre
twos.
apart. 1 metre apart.
2 metres apart.
2
Mr.
metres apart.
Casson.
It's not.
We
It's
need
not
2
possible.
metres
I'm just
apart.
saying that's not possible. 2 metres apart.
2 metres apart. Right, 2 and a 2. Beautiful. Does that one have any more 2s? No, it doesn't.
No.
So I'm going to go 3 and a 3. 3 and a 3.
Put them in the middle.
Oh no, I've missed out a step, Mr. Casey. I've missed out a step.
Oh, what have you done?
What step have I missed out?
I don't know.
I haven't
You've labelled them.
labelled.
Oh, big mistake. Often happens. People don't label and they get confused.
What do I have left? I have a 2 left and I have a 3 left.
Goes in there.
Beautiful. Now I
Lovely.
can start thinking about those key
Highest common factor.
words.
Highest common factor.
I remember highest common
Lowest
factor.
common multiple.
Highest common factor is just the middle multiplied
It
together.
is easy one.
So 2 times 2 is 4.
Yep.
4 times 3 is 12.
Yep.
12 times 3 is 36. Beautiful. Now I've got to times all of them together, but I've already done that.
That's
So
already
I just
36.
need to times it by 2, which is 72.
72.
And now I need to do 72 times 3. Let's say I can't do that. I'm going to use this method because this is my method.
I hate this method.
And
Go
Mr.
for it.
Casey hates this method, but I love it. It is a hashtag Mr. Massey method.
Shout out to Mr. Massey.
216.
Oh, nice. Nice.
And we're
I
done.
quite like that method. It works.
I mean, I really do enjoy it.
Mm.
It changed my life.
I only don't like it because it's Mr. Massey's method.
5 years ago, Mr. Massey changed my life with this method.
It's a Bristol method.
So, that is that. Now, what we want you to do is, where you've seen this link, on Show My Homework, there are now some tasks for you to do on Sam Learning. There is also an extra lot of exam questions with solutions attached. We want you to go for those now.
And did you spot the banana? If so, email us in. Let us know.
Also, follow Knole Maths on Instagram.
Thank you very much.